Okay, it's time to have our class. Okay, I'll share my screen. All right. I'm going to start to talk about chapter 2. Any questions about chapter 1? All right. And very good. No problem. No questions. Okay. And I just remind all of you that we will have assignment due next week. Okay. So you can do that. You can prepare it at home first. Okay. And I also want to have your name on our line groups. Okay. And you can decide it which one will do the presentation next week. Okay, I mean that when you need to come to the class, then turn in on the side turn into the iLearning system. Okay, then I already did that. Maybe I can show you. You're familiar with the iLearning system? Some of you may, but some maybe not. Okay, and oh, let me start it with I need to. Okay, and this is our classes iLearning system, and I already announced our class activity 1, which is due on October 6th, and I also put that. Okay, let me see. Where is it? Office. Into the classroom. And maybe here. Then I already put it in the iLearning system, okay? And which will start 9 o'clock next week, next Thursday, and due 10 o'clock, means at most 1 hour to let you, upload it. But as long as you don't have any problems, okay, you can just come to the class and upload your homework. Then we start do the presentation. So every group should have one student, then come here and do the presentation. When you do the presentation, just present your homework, your assignment, okay? Whatever you turn in the iLearning system. Understand what I'm saying here? Okay? All right, so this is the assignment due next week. Okay. Then, what else? Okay, so let's start at chapter 2. Okay, chapter 2 is about the foundation of regression analysis. Some of you, what is it? What is this? What is it? How do I do with this one? Let me see. Okay, turn it off. Let's see this one. All right. And in chapter 2, we have 7 sessions. Okay. And actually, for the first 5 are those I need to do some explanation. Okay. And especially for 2.1, 2.2. Okay. We are talking about how to estimating the single independent variable models with OLS, and 2.2 just extend the single independent into multivariate, or we call multiple regression models with OLS. Okay, and with these 2 sections, I wanted to summarize the reasoning behind and mechanics of the OLS. OLS, I'm going to talk about that in detail. OLS means ordinary least squares. Okay, and we want to summarize the reasoning behind and mechanics of the OLS, and also understand what OLS attempts to do and how it go about it. Okay, and the 2.3 and 2.4, okay, is to, after we talk about how to do this ordinary least squares methods, then we'll learn how to evaluate in the quality of a regression equation, okay, and describing the overall fit of the estimated model. And in these 2 sessions, we can learn how can we tell a good equations from a bad one once it has been estimated. Any criteria? And does the estimated equation fits the actual data? All right. So with these 4 sessions, then we will have an examples. Okay, then 2.6 is a summary, and 2.7 is what we call econometric lab. We do have many econometric lab along the chapters. Okay, some of them, many of them are very good. So in this semesters, we will do much of the econometric lab following. Okay, all right, and with this general idea in mind, then let's start talking about ordinary least squares. We say the foundation of the regression analysis, usually this is a good expression, say the bread and butter, because bread and butter is the, essential ingredients in our nutrition. So this is what we say the foundation of regression analysis is the estimation of the coefficients of econometric model using a technique called ordinary least squares. Okay, I know that some of you, if you learn statistics undergraduate and you will still remember what's the regressions, then what I'm going to talk about is pretty easier, to you. But if you don't understand it, you never learned the statistics, I know that at least 1/3 of our students do not have any statistics background, then we need to learn this carefully, okay? And pay attention to the what I introduced today, okay? And later on, I have some math. It's not that important, okay? But the idea behind the ordinary least squares methods, OLS, okay? We need to understand some math. So you need to see some notation like this one, okay? If you're not really familiar with those notations, you need to understand this one and start to learn it, okay? So OLS is a regression estimation technique. So it's a technique that will calculate the beta. You all remember what's the beta? The coefficient of the equation, right? We have beta 0, we have beta 1, beta 2. If we have k x variables, then up to beta k. And we will calculate the beta. Look at this one. I have a head on it. Means what? Means we do have actual x and y values, data set. Okay? Then plug all these numbers in. Then we can estimate the beta. So calculate this beta so as to how to get what kind of betas we will get it. Okay, as long as we can minimize the sum of the squares residuals. Remember what is residuals? The residual is using actual y minus the estimate of the y. Remember that? Okay, so what do we mean by estimate, actual y and estimated y? I need to show some diagram here. Maybe it's easier to understand it. Okay, I'm always using single x variable. All right, so if I have some data, something like this one, right? Okay, and I will estimate it, a line. Which maybe is like this way. Okay, so this line is turned out to be y hat equal to beta 0 hat plus beta 1 hat, then x. Okay, so OLS is a technique. They wanted to calculate this beta in order to minimize the sum of the square residuals. Okay, look at this. This is some x variables called x1. Okay, and since the line, the dot is here, so the actual y is here, right? And this is the estimation line. So if we plug the x in, okay, and we do have these two numbers, and we will get the y hat. So where is the y hat? Should be like here, right? So this is y1 hat. So this is what we call residuals. And this residuals, since we use y1 minus y1 hat, so this residual, the sign should be negative. All right, so take this one as an example. Okay, this is another x. I call it x2. And this is the y2. Okay, then actually this one here is y2 hat. So this way, this is EI is positive. So EI can be positive or can be negative. Okay, then we square it. Look at this one. I square each one of them. See what I have it? Square it. Why do we have to square it? Because if I don't square it, then some of them is positive, some of them is negative. They will cancel out. So I don't see the difference. I cannot see the difference without the square. If I add them together, if this line is good enough, then the positive residuals and negative residual will be canceled out. Okay, therefore we need to square it. So no matter it is a positive difference or negative difference, the difference is a difference. After I square it, the difference can be compared, right? So either this is a positive if the EI here is positive 2, and if the EI here is negative 2, if I don't square it, it turned out to be 0. But if I square it, this one turned out to be 4, this one turned out to be 4 too. Understand what I'm saying? So we're trying to get the line in order to make all this difference. You know, I just showed two dots, 2 data, right? Actually, I have many data in. So I have to calculate every one of them and square it, then add them together and try to minimize it. That means this is the method of what we say ordinary least squares. Understand what I'm saying here? All right. All right. So any questions about this? Then this is the equations where, you know, I show on the diagram, and this is actually this is equation, right? And usually if I have this models, we will put this one is called arrow terms. So statistical equation is different from mathematical equation. Mathematical equation is the one without arrow terms, but statistical model or equation always with arrow terms, because, you know, the variation of y most of the time or sometimes cannot be explained just by x variables only. Okay, there are some variations. Even the random arrow will be in the arrow terms. All right, so this is the equation we estimate like this. Okay, so we obtain beta 0, which is the intercept, and beta 1 is the slope. Okay, so again, so that the sum of them is minimized. So we will get the formulas for beta 0 hat and beta 1, which is on your textbook on equations 2.4 and 2.5. So if you have the book with you, please turn to the page. Mine is 57. We do have the formulas for 2.4 and 2.5. Okay, let's see whether I have this one. Okay, let me, remind you that OL is relatively easy to use, which is minimization of the residual, the sum of the residual square, sum of the residual squared, appropriate from a theoretical point of view. And OLS estimates have some number of useful characteristics. This is the first one I'm saying that. We have positive residual and negative residual. Actually, the sum of them is equal to 0. Okay, and the second point is OLS can be shown to be the best estimator under a set of specific assumptions. And we will talk about this assumption in chapter 4. Okay, I think we'll do some examples, then we go back to this very, very math parts in chapter 4. Okay. All right. And I need to explain 2 words. One is called estimator. The other one is called estimate. What does these 2 words mean? Estimator is what we call a mathematical technique that is applied to a sample of data to produce a real-world numerical estimate of the true population regression coefficient. So in other words, OLS itself is an estimator, and those beta we estimate using OLS is what we call estimate. So estimator, in English, this words is noun, right? And it's kind of here we just say it's a technique. Okay, so if you see the words estimator in the book, you have to remind yourself it is a mathematical technique. And so far, the estimator we learned now, so far, it's just one, which is called OLS. Okay, so later on, even next semesters, if you take the course, then we will finish all the rest part of this textbook, and we will tell you other estimator which is useful, especially for your thesis. Okay, all right. But for this semesters, usually, we're just talking about the estimator, which is OLS. Okay, and I also like you to remember the words parameters. Okay, when we say parameter, okay, parameter is the number which describe the population. Okay, parameter. I think this word is important in statistics. Parameter is a number, okay, which describe the characteristic of the population. Okay, and the other words related to parameter is called statistics. Statistics, these words, is also the numerical numbers to describe the characteristic of the sample. One is population, the other one is sample. Right? Whatever using Greek letters, like the beta we have, okay, is the parameter. And whatever we put the head on it is statistics. Since the parameter describe the characteristic of population, so this number will not change. The parameter won't change. But the statistics is describe the characteristic of the statistic samples. Therefore, if you had different sample, then the beta will change. So in other words, if I wanted to estimate this one, okay, now I have a data set which show on this line, then I can come up with the numbers for beta 0 hat, beta 1 hat using OLS. But again, if I do have some other data set, also is same as this Y and X. I mean, the same means the variable is the same, but the data itself, since it is the different sample, so the value will be different. If I have different data set, then I will have different beta 0 hat and beta 1 hat, even I have the same X and Y. Understand what I'm saying here? That's why we put a head on it, because that is the estimate. So an estimate is a statistics. Okay? All right? So this is basic ideas about statistics. Okay, and what we learned, the regression analysis actually is one popular methods, okay, especially in business school. I know that some other schools also learn the regression, but regression analysis is popularly used, especially in business school. Okay, all right. And now I wanted to tell you how does the OLS work. Okay, so again, you will see this kind of notation on and on. Okay, until you really, put into your mind. Okay, especially those, see this first time. Okay, the EI square actually is equal to YI minus YI hat squared, right? And what is YI hat? Actually is this beta 0 hat minus beta 1 hat x, just like that. Okay, so using calculus and algebra. Have you learned calculus? Have you learned algebra? Okay, the formulas 2.4 and 2.5 is what we say using calculus and algebra. And also the derivative of above equation. So this is all about math, okay? Then we can get beta 0 hat and beta 1 hat, okay? Then I'm not going to ask you to do all this proof to say how to get beta 0 hat and beta 1 hat. What you have to do is just know what's the formulas on it, okay? And actually, you don't have to memorize those formula. You never do that since we have the computers. But before we know the formulas, I think we can just use one example to do the practicing. Okay, then just once for all. We do once, then you will appreciate what all this computer work help us. You don't have to do it by your own hands. You don't have to punch all the calculators. You don't have to do that. Just use the eViews computer packages. Then all the numbers coming out. Okay? All right, but we need to do once for all. All right? Okay. And this is the formulas for 2.4 and 2.5. Okay, I think those of you, if you don't familiar with the math, I think this kind of formulas make you headache, right? It's so tedious, and those notations even drive you crazy. Okay, but this is the easiest one, since this is just single independent variable. Okay, and let's do, everybody turn your computer on, okay? Then you do have the data HTWT1, right? Okay, this is data from chapter 1. You all remember that data? We have 20 observations using that data set, and I'd like all of you to put it into Excel, okay? In Excel form, do not use the eViews form. You know how to do that? Download it from the data set and download the Excel form. Then I'll do the same thing as you do. All right, let me get out of my printer here, and I need to have the data set, right? So I need to get the data set from the class, right? Oh, come to the class. So I have this data set, all right? And let me download it. And let me put this one here. Huh? They haven't done it yet? Okay, I should have it in my, okay. I'll turn this on. And I have this data set here. Okay. I have this one, and let me also get my eViews too. Okay. All right. Okay. Look at this Excel file. Okay. Remember, let's remind you that the formulas, we will get the beta 1 first. Then we can get beta 0 hat. Okay. How to get beta 1? This tells us that I have numerator and denominator. Right? Denominator is using each one of the x minus x bar. X bar is the mean of the data, right? Okay. Then square it and add them together. All right. Then what I have on my numerator is using individual x minus x bar times the yi minus y bar and times together, then add all the observation together. So this means that I'm doing all of them. So I have 20 observations. So I do have 20 of this one and some of them. Then this one is I also have 20. So square it, then some of them. Okay, so I'd like all of you to do the practice which will turn out exactly the same as what we have on your textbook 2.1 on page 58. All right, so what to do? We need to have term which is x minus x bar. So I need to know the x bar first in order to do the calculation. So how to do the x bar? You know, those of you never use Excel, please learn it by yourself, okay? Okay, but I will show you, in the class, I will show you how to do it. But after the class, please learn it by yourself. Okay, all right. So if I want to know the mean, okay, I can add them to, how to get the mean? I can add all of them, right? Okay, then divided the observations, number of observation, this is mean, right? But we can also use the formulas in Excel. So I can use formulas and I will insert the formulas. And there's a function called average. Look at this one, then I choose average. Okay, then it will ask me that where do I get the average from? So I'm starting with the B2 up to B21. Okay, then I think this is right. Then okay. Then this is the mean. Did you see that? Okay, maybe I'll insert one row to make it clear. Okay, so this is the mean. So with the same technique, okay, I can copy this one. Sorry. I can copy this one to this cell. Then so this is the average. So you can see from our textbook, for y, the mean is 169.4, exactly as what I have. And the mean for x is 10.35. Okay. All right. All right. Then what should I have? Now I wanted to have x minus x bar. Okay. I just say x bar. Okay. So I want to using, so this one is equal to using B2. I want to use this 5 minus what? Minus this numbers, mean. Okay. So I do this one, and this is in B23. B, okay. And I put the dollar sign here. Okay. This one. I put a dollar sign here. Just do as what I did, okay? Okay, then I will have this one is exactly the one you have it on your table 2.1. Okay, why do I do this one? Okay, I'm using, if I don't do the dollar sign here, look at, okay, so if I don't do the dollar sign here, look at this one. This one is using B3, so using this one minus B23. If I do the copy for the following cells, it will, this numbers will automatically change. Okay, but if I put the dollar sign here, it shows the computer that this numbers is fixed. Okay, so do the same thing as I did. Okay, then after that, I will use y minus y bar. Okay, those already know how to do it, bear with me, okay? Because we have at least 1/3 of students, is totally out of mind, okay? So I need to really take care of them, okay? So please pay attention and, bear with me, okay? All right, so I do the same things for y bar, and this is equal to C2 minus, then I will have C23 too, okay? And again, here I need to put the dollar sign, C23. Okay. Okay, you can check all these numbers exactly what you have it from your textbook. Maybe, the position of the column is not the same, but actually, for those is okay. Then I need to have a square of the x minus x bar. Okay. How to get a square? So this for this column is called, I can put them, okay, and I need to have square for it, right? I want it, so I just say SQ squared, okay? All right, and how to do the squared? I need to using this column and square it. So equal to, so like this one is D2, right? If you want to square it, put this sign. Did you see the signs here? This one. Just like the hat, okay? Then this means squared it in Excel. So do I Excel it? Yes, you 5.35, 5.35, then square it. All right. Okay. All right. Then the last part I need to know is is this column multiply this column. Okay. You know, in my numerator, I need to have this one times this one and sum them together. Okay. All right. So what I'm going to do is just using equal to D2 times, using the star sign as a times, okay? D2 and E2, right? Okay. And according to the formulas, I need to have the sum of the x minus x bar square. Okay, so I can add all of them together, and this is for sum from A, B, C, D, E, F, F2 up to F21. F2 up to 21. So the sum of them is 92.55. Hey, how come I have two? Here is 50. Maybe the decimal places. Okay, I have more decimal places compared with the books. Okay. And I also have to sum of them. What did I do? Okay. Okay. Yes, this is the same as what I have. Okay, up to this point, you have everything. Did you see that? This is what I have for my denominator. This is what I have for my numerator. Okay? All right. And okay, let me put this one a little bit here. The formulas. If I want to get beta 1, multiply this and sum them. And also this one, the sum. Okay? And I do have the numbers. I have the numbers, right? So this is 590.2, and this is a new denominator, 92.55. Okay, so look at this one. We calculate using the number we just have it, and this is 6.38 in terms of the beta 1. Okay, then according to the formulas for 2.5. Okay, after you have the beta 1, you need to use the x bar and the y bar, doing these formulas. Then you get beta 0 hat. All right? All right, so this is the number we have it. So we have the slope, it's 6.38, and we have the constant, which is 103.4. Okay, then do you all remember that we have done last week using the eViews, right? Then I have X and Y, and I do the computer work. So I will hit Y first, then X, and I open it as an equation, and did you see that? Least squares. This is what we just talked about today. Least squares methods. Ordinary least squares methods. Okay, and this one, you all remember this output? You all remember this output, this X, the coefficient is 6.377. You know, I just used 2 decimal places, which is 6.38, right? In our calculation. And 103.4 is using formulas. Okay? So this is what I say, once for all. We just do once. And you know the procedures. After you know all these procedures, and you will appreciate that the computer work, you know, here using the eViews, they calculate this coefficient for us just within 1 second. Okay? Okay, and the way I teach you how to use the Excel, I think most of you need to collect the data with, you know, in the future if you do your thesis. Okay, all the data collection most of the time using Excel. So you have to learn Excel, okay, by yourself, please. Okay, that do you better. And I will show some of the, actually I will show some of the Excel work too in the class, but not all of them. So please remember to, you know, just learn it by yourself after the class. And I will do some in the class related to the class. Okay? Any questions about this, what I just showed you? Okay, let's stop here for a while. Then we'll come back later, okay?